Before I start, I have a stupid joke to make. So, how many Argentinians do you need to write a rendering engine? Just one. I know where the exit is, so I will get myself out later. So Juan is after me, I think. So, okay, so I'm teaching basically game dev at the university. I've made lots of random games since Commodore 64. I'm currently co-creator of Zero Factorial Crunch Entertainment, which with the guys over here. So this is my my credentials. This is my best award I ever received. So this is from this year 24-hour game jam from my students. This is award basically tells me that for the best menu settings in the game. I made the game in 4 hours alone, and it was horrible. But the award is like heartwarming. So before that, I worked on witchcraft. You might know it. It was made in Godot, so I will spare you the video. Right now we have Aquabyss that's being ported from Amiga. This is a game that was created for how long? Like 13 years? Or something. It's in constant development. If you play Amiga games still, then you can just grab it and play it there. And soon, I hope we'll have it on Steam. So it's basically Aquabyss. It's basically a trading adventure game, story-driven in the world where Captain Nemo is. So. Yeah, and you can place also flowers somewhere over there. There's Aquabyss presenting it. Enterprise Space Agency Simulator. You will see some shaders from here. And you probably should know at least Rings of Saturn. I recently joined the team there. So I will be showing some of the shaders that the creator of the game made, Codera. So, and, oh, sorry, I didn't translate the first slide, the name. So if you want, like, shaders are really hard to start if you have no idea how they work. So this is some links you want to try out. Like GDQuest is doing a workshop right now in the other side. So there's lovely shaders over there. There's some other dudes and my shaders from the game that's below. And there's some links, and I will just go to the coding part. And this might explode, my laptop might die, so expect very hectic presentation. But okay, normally I wanted to go over step by step how to do a shader, but I expect most of you should know something about it. So I'll skip you boring parts. I can show it how the shader look like, but I will try not to discuss it much, except one maybe. So the first shader, it's like standard dissolve. You probably know it. You usually need it for something like something gets dissolved. It's quite common shader. It's basically like either you want to get rid of something, like if I don't have a background image, then the front one just disappears, right? Let it play, or shows whatever which way you would want to animate it. And let's just put on the background. And the shader is, if you don't know how it looks like, then I will show you, and it's not that terrible if I just find it. So here we go. So that's it. So that's not very complex. Let's just make it a little bit bigger. So you need to have a texture that you want to dissolve, basically the position of the dissolve, so it's basically normalized variable from 0 to 1. You just sample the texture, and you can use a noise texture to use the dissolve. So in this case, it's a standard Godot generated one. I can just click it and create a normal texture somewhere here, noise texture, sorry, and just use that. And you basically modify transparency of the original image based on the noise value of the texture you have. That's it. Super simple. So screen you see here, it's from placeholder art from Aquabyss actually. And I have some other shaders that I developed strictly for this. So let's go to file system, and I have something that you should know from somewhere. And I wonder who knows where this shader is from. Not strictly shader, but effect. Scene, animation. So it's a little bit slow, but do you know how this is called? It's written somewhere there. So this is a single wipe, and you probably know it from Star Wars. Star Wars used it for the first time. It just wipes the screen from one side of the other, and they used like many different angles. In my implementation, you can actually randomize the angle or which way you want to swipe it. So let's just grab it. So the shader is a bit longer. So you need to have an angle of the swipe you want to get. There's some like normalization, rotating UVs rotation, and basically you get the same idea. It's the same as like the dissolve, but you put up something different. So basically it's a sinusoid that is clamped on both sides. And another one that we actually use, and it's a little bit more customized for the game, and that's single wipe with dissolve. It goes like this. And I'm already half of my time is done. So it gets, so it like looks like it was supposed to look like a burning paper, but we decided, okay, let's not add any special like fire or something, just blend it like in a weird way, and that's okay. Okay, so I can stop this and let's go to the next one. Okay, so this is a planet. Believe it or not, we have a sprite. It's super simple. We have a sprite that is like 2 by 2 pixels and it's white, and we generate a planet out of that. So let's go into the shader and let's do some live coding. It will definitely not explode in my face. So let's. Come on, get it. Okay, there's another planet, and yeah, I will definitely not see what's inside here, but anyway, we need a name of the functions. Anyway, those are, one of the links are published and they are open source, you can use them, at least the planets one. So what's happening here? First, I need to do some scrolling because we want the planet to rotate, so I get a scroll value, so basically rotation of the planet. We remap UVs a little bit using that scroll, so we will be scrolling over the screen. And let's actually grab something. Let's do this. Okay, so this is a sphere basically in a black background, which we really don't want because we want to have a planet that's basically the black part is transparent, but still. And there's a function basically that converts our UV coordinates on screen on texture, which goes from 0 to 0 to 1 to 1. And we get a normal from that, because I can map the position on screen on a sphere. Basically, I get a position x, y, and I calculate the z value, so I get the normal value of a sphere. So for that, I use a simple, I will not call it simple math function, because if you like never did this before, it's never simple. Let me just show it like this. So it's basically this. I get the normal value, I get the z to a uvx and uvy. So that's it. But if you don't know how to write it, then it's terrible. And it took me a long time to actually figure out the basic math for that. And we get like a sphere shading. And if I have some sprite, okay, I can control the light, right? And the another function is a getLight. This is a standard Blin or Phong shading, or Blin-Phong shading, no, not really sure which one. So we basically get the direction of the camera. Since it's 2D, then the camera is always like this. So it's 0, 0, and we are on a Z level away back. We calculate a half vector between the light and the camera direction. Light is basically the position of this weird controller that I have here, right? This is our lights. It's snapping. Why it's snapping? Doesn't matter. Anyway, it's basically position of this cursor, right? Oh, geez. Come on. And we calculate diffuse, specular, and those are basically an ambient light. Those are three components of light in most simple shading you can get, right? So we have a sphere. Then we want to like cut off the area outside of the sphere. So we calculate just a fade outside, right? Simple. It's not that terrible, basically a smooth step based on the distance from the center, nothing special. By the way, we need to get that option to hide this. Really, we need this. It's I don't know still why we cannot use normal Godot editor instead of the shading editor. It's a bit clunky, but still. Sometime we'll get it, I'm pretty sure. And yeah, and finally, there's some texture that we can actually add. And let's add the texture. So this is our planet. Let's add a texture. There's an image color, which I will change the sampling now. So we get something like this instead of this. Edge fade actually is important instead of this. Right? So what we get doesn't do anything. But now we can sample the texture, and the texture we'll create is a 1D gradient, and let's create it. So let's get rid of this. Let's add the poles. Let's add some color. Let's make it colorful as we can get. So yeah, we have like weird colors, gas giant or whatever we want to create, right? So starting to look like planet, and still it's rotating, but we don't see that. And final part we can do, we can just add something like that, and that's basically distort based on noise texture again. So there should be some overlaps. UV sphere, where is it? Is it this one? Texture color. Probably I just do this. Okay. So nothing changed really, but now we have an option to add a noise texture. So again, let's add it noise texture, like standard whatever. And one thing we want to check is that it's looping seamless. And now we can basically change some variables that I have here, not in the noise, like, where is it, the convexity? I don't know what that does. Margin is basically the size, how specular the light is, how much we get reflections, and there should be something that noise, okay. So we can displace it with noise. So if I get it to max, then you can see that's basically the noise texture. That's a simple way to create a procedural texture for a planet, right? Okay, so the shader right now looks like this. I will show it in total. Yep, I got it over here. So let's see it. Let me just remove the unnecessary bits. So that's it, right? That's the shader, and plus two function that gets you the normal from the sphere, and basically basic shading for a blink-fong. If you don't know what a blink-fong shading is, then I congratulate you. If you don't worry, it shouldn't matter to you. Okay, so let's go next. So this is the Just Giant. So we can create the same way. We can use a normal texture of a planet, which there are plenty. So this is Venus. It uses the light we have here. We can shade it. If you want, you can put the light behind, but you need to just change the Z level. So it basically pretends that there are 3D sphere and it's still a sprite. You can replace the texture if you like. So I have it here. Let's find it, and I got some more like Neptune, or what else? Venus, Mercury. Yeah, super easy. Next one, we can create rings. So rings looks like this. It's again sprite that the texture that is 2x2 and is white. Inside we have a shader. That shouldn't be too complicated a bit. Basically, we create a mapping function that creates a ring for us. So we map it on a circle and with radius, inner radius and outer radius. We can actually tweak it like inside, outside. As input, you can input a texture, or you can gradient, put in gradient, and there's some fake edge to add shadows that you can see it doesn't work really well, but doesn't matter in this case. So next we can add it together and add some the fake light. We have some like random planet. It's supposed to be Saturn, but it's not. And if you really want to get ugly with the shader, you can get a planet that's rotating all over the place, and it's throwing the shadow from the rings to the planet. And that's where the magic part comes in. I will not even try to explain how it is done, because just lots of math. And still we have the dynamic light, and you can tweak it. The rings draw shadows on the other sprite, and it's still, this is a 2x2 sprite, it's 2x2 sprite, so how do we fake that it's going behind or in front? So we have one part and the other part, and yeah, and the sphere itself, it's still just three sprites with some shaders, right? Okay, so yeah, you can grab those shaders on a link that I shown before. I'm pretty sure you can find it from the recording, so you can get all the planets. Next, something different. This I wrote like 2 days ago, like last week. Last week? Yeah, last week. So this is something else. Basically, this is a simulation. So what we have here is a viewport. Raphael told us about viewports, so more viewports is always better. You will see that later. So I have a viewport. Inside I have basically a sprite and 2 other sprites that are really doesn't matter. They are just circles, and they are used for showing them or turning them off. But anyway, we have a sprite, and it has a shader. And the shader looks something like, it's not that terrible. I haven't cleaned it, so let's just remove this. That's the shader, right? And this actually is a wave equation. So if you want to like pretend there's some rain falling onto the objects, and you want the waves to look like real, kind of. It's a super simple approximation, but still, you can just write it. You can find the code for that, and it's basically this equation is the most important part. The rest is just some trickery to copy the buffers. So basically, red channel uses the height value, the blue channel has the height value from the previous frame, and green channel uses the same but the frame earlier. And let's just run it. So that's the right part that you have. We see nothing there. Okay, actually, let's do, right? So we can see something over there. Like I'm clicking, and there's some waves coming, like spreading around. So that's the basic simulation. It's I used to do it in 2 viewports because of the buffers I told you before. So you have to copy you need to have basically a frame before the one that's being overridden now. And you had to like use two viewports and render from one to another and back forth. But now you can do it with one sub viewport and rendering with like none of the background, and do not clean the output. You basically don't clean the output. You have the information from previous frame and just copy it to the 2 different channels. So okay, what do I need that for? And I need that for to make again sphere with force fields. I always want to do something like that. I want to have a spaceship. When I hit it, it's just does something to you can see where the hits are. And there are some like standard variables. One is basically how big is the impact. So you can have lots of small or like laser doing some stuff over there. And the other one is how fast the simulation is going, and basically the wave equation is limited to a wave travel this speed. So you cannot make it like super simple. You can make it super slow though. And if you turn it off, you can basically draw to the viewport, right? Can I? Ah, yeah, smiley. Okay, how many? 4 minutes. Fuck. Yeah. Okay. So that's the one. And okay, this is something else. This is something that I always wanted to do is, if you probably see some like websites where there's a weather pattern or something, you will see something that's called a wind shader. You can actually Google that. And I always wanted to code that. So basically it shows you the vector field of how the wind's going around the Earth or whatever. And it shows you like creates a particle, the particle travels along the vector and it leaves the trail. So basically this is it, but the particles are persistent. Not exactly in this case, but you will see later. So they are created and the shader is keeping them alive. Like they know exactly where the pixel is and you can travel in sub-pixel. So it has a better precision than per pixel because in colors you can actually store the position data. And you basically keep the information from previous frame and you can create something like that. Why is it important? It's not really that important here, but I'll just open this. Yeah, so I need to open it because it would crash my laptop if it were running in the background. So this is something that Mariusz Kodera made, the creator of Delta V. So I shared my shader with wind shader, basically. I call it wind shader. And some other thing that I will show later, just on the last page. So anyway, we're trying to make a game out of it. So what's happening here? We have a couple of buffers that do exactly the same thing as previous one. We have like lots of agents. They are animated. We have actually a version where they overlap and they appear to be in 3D. They are doing pathfinding to the sources of food, which is green. So if I, for example, draw here, then some of the dudes will separate and go for the food, or maybe this way. So you can see the information of the pathfinding is propagated over time, which we can actually see here. It's basically a vector field to the nearest like objective plus avoidance from collisions, so they don't want to get to each other, and we get agents that want to grab some food. They going through the bottlenecks. You can draw them more, and it still calculates in the same time. So basically, it's can run a couple of millions, I don't know, 1K, how many pixels is that? That's a lot, right? So 4K, how many pixels is that? So that many agents you can get in the same time of calculations, whether it's 1 or 4 billion, it's the same. So yeah. We have a collision information, and basically any code that's written in GDScript, it's here. This is the only code that's in GDScript, and that's just painting I did. Everything else running on shaders. And you have 1 viewport, 2 viewport, 3 viewports, 4 viewports, 4 viewports for that. I mean, Rafael would be happy. So that's a thing we want to create a game out of. 52 seconds, nice. And the trick is why we did this, because we can calculate a frame, right? Frame by frame. And the state of the world can be saved as this image you see before you, like all the weird shit and running in the viewport as well. So if you save this image and you can send it to someone else, then they have a full state of the game, right? So now, if we want to create a multiplayer game out of it, so only thing that we have to care about is to synchronize the inputs and synchronize it until to a certain frame, right? So in frame 1000, someone shoots, then basically you just have to synchronize the calculation on both the sides, and you have a deterministic simulation. But this doesn't work because this stupid thing, AMD and NVIDIA is actually calculating like a square root or some basic shader function differently, and it doesn't work on some like edge cases. And we tested it for like, I don't know, 60,000 frames or something, tested in multiple computers, and there was 1 pixel that was different. And that's basically screws the whole idea of the game. So right now we are thinking how to write the base function ourselves, not to use the built-in math function. So we have basically one-to-one regardless of the machine, just to make sure at frame 10,000 have the same output on all of the machines. And we can have a multiplayer, like crazy optimized multiplayer. But we'll see. Okay, and that's it basically. I can show off one more thing, but you can ask me a question now if you like. I know where the exit is, so. Yeah. Okay. So if you want to ask me some questions, then grab me here because we overreached our time. And one last thing I forgot to show you. This is the planet shaders you saw, and this is the asteroid ring. And if you like zoom really hard to it, there's a ton of asteroids. Like there's unlimited amount of asteroids, and it's still the same shader running on screen. And basically, for a 2K texture, you can render each pixel can be separate asteroid. So basically, the data precision is the only limit here, which you can, if you go outside of the world, you probably can see that things are like jittering, precision loss. So this eventually happens if you wander too deeply into the shader stuff. Okay, thank you.